Nassim od ponad 30 lat prowadzi niezależne badania naukowe, których celem jest poszukiwanie powiązań fizyki z matematyką, geometrią, kosmologią, mechaniką kwantową, biologią, chemią oraz antropologią i starożytnymi cywilizacjami. Wieloletnie badania i wyjątkowe poświęcenie Nassima Harameina dla rozwoju nauki wydało owoce w postaci przełomowej teorii unifikacji wielu referatów naukowych oraz opatentowanych wynalazków, dzięki którym zyskuje coraz większe ogólnoświatowe uznanie. Przestrzeń jest wszędzie. Łączy skalę kwantową i cząsteczkową ze strukturami w skali astronomicznej przeświata. Dlatego zastosowanie wiedzy na temat podstawowej geometrii przestrzeni ma kluczowe znaczenie we wszystkich odkryciach Harameina. W artykule naukowym Grawitacja kwantowa i masa holograficzna przedstawia rozwiązanie, które pozwoliło przepowiedzieć promień ładunku elektrycznego protonu z większą dokładnością niż model standardowy. Wartość Harameina została potwierdzona w eksperymencie przeprowadzonym w 2013 roku przez naukowców z Instytutu Paula Scherrera. W 2004 roku Nassim Haramein założył The Resonance Science Foundation. Haramein, dyrektor badań naukowych, kieruje zespołem fizyków, matematyków i inżynierów. Bada zasady unifikacji i wszystkie ich implikacje, które pomogą rozwiązać światowe problemy dnia dzisiejszego oraz przynieść korzyści dla przyszłych pokoleń. Od jesieni 2014 roku The Resonance Academy oferuje kurs ujednoliconej fizyki The Delegate Program, w którym bierze udział kilka tysięcy osób z ponad 70 krajów. To pierwszy i jedyny tego rodzaju kurs na świecie. W 2015 roku Haramein rozpoczął pracę we własnym laboratorium. Kieruje zespołem naukowców i inżynierów, którzy pracują nad wdrożeniem jego nowatorskich teorii i patentów w technologiach wykorzystujących energię próżni oraz oddziaływanie grawitacyjne. Technologie tego typu mogą rozwiązać światowy kryzys energetyczny oraz otworzyć drzwi do eksploracji przestrzeni kosmicznej w sposób, który jest zarówno całkowicie bezpieczny, jak i przyjazny dla natury. Niedawno nakręcony film dokumentalny The Connected Universe przedstawia odkrycie Nassima Harameina oraz zawarty w nich potencjał dla przyszłych pokoleń. Szanowni Państwo, Nassim Haramein.
Thank you. Hello, Poland. It's been a long time I've been wanting to come here. Everybody, you know, Eva made this happen. So thank you, Eva. So good to be here. I wish I could speak Polish, and I'll practice. It sounds beautiful. So we have a great evening together. We have a lot of time for average, presentation. But many of you know, sometimes I take 12 hours and, so next time I have to come for longer, right? It's so great to be here. Throughout the years I've been hearing so much about Poland, people in Poland asking me to come, and it's been, really, I can feel how much interest and how much the Polish people have been, touched by this information, how much change it has to do for so many people here. I get these most wonderful letters from people in Poland, and I feel like more and more, and especially in Europe, this information is starting to actually break through. So, I really want you to feel encouraged that it actually is happening. As much as the world, I don't know if you follow the elections in the US and all the craziness and all this stuff, and everything that's happening around the world, not just in the US, but what's going on with Russia and everybody else. And there's something changing at the same time. As much as things are breaking down on one side, you know, and very strange people end up being elected, you know. There is, on the other side, you know, sanity coming. And it's coming because a new understanding of the structure of the universe is emerging. And it's not just emerging from the scientific community, it's emerging as well from the spiritual community, from the everyday people feeling a change inside themselves. And it's happening in all levels of society, from inside the institutions, inside the governmental structures, inside the financial structures, and everywhere. And that change that's occurring with people is that people start to feel connected. They start to feel that there's something bigger than just the individual that is connecting all of us. And you know, that thing that's connecting all of us, we're starting to get a sense of it in terms of the science. And this is what's great about the science, is that it takes it out of dogma, because prior we would think of some kind of God sitting on a throne, you know. It's usually a male, by the way. And, you know, with a long beard and a pair of binoculars, making sure that you don't mess up, you know. The big stick. And we're realizing that actually we're connected through a field of information. A field of fluctuation at the very fine scale of the quantum level, at the very, very granular scale of the quantum level, where information is being exchanged across very large distances by entangling all particles together. So that you are not isolated from the rest of the universe, but actually, although you're teeny, weeny, teeny little thing compared to the universe, you are part of this amazing will work of information that is informing the universe about its state. And so in this sense, the field of information that you're participating in and the structure of all the relationship that you make throughout your life matters in the universe. And I mean that literally. It makes a difference. You make a difference. And when I say you, I mean you in a non-trivial you. Are you guys having a hard time translating back there? I'm trying to not use too big words. Is it working, everybody? Yes. And what I mean by a non-trivial you is that you're made of an amazing complexity. There's an amazing miracle occurring every milliseconds of your existence. And that miracle we take completely, typically, for granted. That is, you're made out of 100 trillion cells. Whoa, I lost a few trillions there. Right? 100 trillion cells. I mean, when you say me, when you say I, right? there's 100 trillion cells that could go, wait, there's 100 trillion of us, right? Okay, what do you mean I, right? And so, and then every one of those cells is made out of 100 trillion atoms. So imagine that, try to like integrate that. Like 100 trillion cell is a lot, right? 100 trillion atoms per cell. So that's 100 trillion multiplied by 100 trillion. That is a lot of stuff. And all that stuff is like happening like clockwork. No worries. Boom, 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 boom. Every second, over billion chemical changes in your body so that you can be sitting there listening to this crazy guy up front. Yeah, that's what I thought. And so imagine the network of communication that's going on between 100 trillion multiplied by 100 trillion, all talking together perfectly, so there's no confusion in all the things that are going on in your body, because if there was confusion, even for a billionth of a second, you would start feeling very, very uneasy. Right? Because like you're talking like a million cell division every second, like if things went wrong, if they stopped talking together in the right way, if all the cells all of a sudden decided that they stopped communication, things would go really bad, really quick. It would be like the worst day of your life, right? Probably be the end of your life right there. So, that's the miracle, right there. Every billionth of a second, that's the miracle that you are. In that network that's running the show in your body, because it's not like you're consciously running the show, because if you were consciously running the show, you would be like seriously overwhelmed really quickly. Your stress level would go up like super high, super quick, right? You think your day's stressful? Try to run, a few billion chemical changes every second, right? And so imagine, how can a society, how can a science actually believe that this stuff is happening under random functions? That this is like just some kind of by chance, it just happened. The atoms just decide to come together and hang out and make a human being, just by chance. And all these chemical changes, they're just because cells are bumping to against each other, some kind of random function, but they just happen to make the correct choice in every case, right? Really? Simple statistical mathematics will tell you that is not possible. That does not add up. Like, there's a huge issue. It's like an elephant is in the room. And, the scientific community is kind of ignoring it. The problem, why is this, happening, why is the scientific community ignoring it, is because when you start talking like this, especially if you're on a stage and you have a suit, they start thinking you're going to say the word God. Right? God is running the show. Right? So then they get really nervous. See, since the separation between spirit or, religion and science, there is this huge, strong pull against the idea of a supreme being. So the tendency has been to try to avoid that by, insisting intensely and against all odds, against all evidence, the evidence being like one human being would be amazing, like 7 billion is like, whoa, insisting that it's random against all odds, because if it's not random, the only other option is that there's a God that's organizing it. The intelligent universe, whatever you want to call it. But there's another option. This is the option that we're discovering now. And that other option is that things are connected. And they're talking. That it's not some God out there, but it's every single thing the God. Right? That everything is connecting and talking, every atom, every molecule, every structure in space is talking through this field of information that makes up reality in the first place. And so that all of a sudden starts to describe a new understanding of the universe, the physics that makes up matter, and your place in it, how life emerged from it. So I'm really excited. I just finished a paper. It's my first paper in biophysics. I only wrote physics until now, but I just finished a paper with Dr. Val Baker, an astrophysicist, and the biologist, biophysicist, William Brown, on the source of consciousness, how consciousness comes into the body, and how biology, eventually becomes conscious. And it just got accepted at Neuroquantology magazine, which is a very good, well-respected biophysics magazine. And thank you. And it describes the conscious event not as something that the brain is coming up with, some epiphenomena of the brain, but actually because the biocrystal oscillator that you are is communicating with the field of information, right? And so like an antenna of a radio. And emitting information back into the field, producing this feedback of information, right? Consciousness is self-awareness, requires feedback. And this feedback is what creates this self-organizing system that becomes very complex very rapidly, just like our fractal equations. It's very effective. It passed peer review almost immediately, very quickly. Right? Because it's very effective. So I think, it's a new era where we understand that our awareness, our consciousness, our being here, our place in the universe is not isolated, but is connected. It's connected at all levels, from subatomic particles to all human beings on the planet. Being part of a field. Some people called it the morphogenetic field, right? And this is changing the way we interact with each other. Because when you're feeling connected, when you have this feeling that you're part of something bigger, a collective of human beings, a collective of galactic beings, a collective of universal beings. Because whether you like it or not, you are on a little planet that's orbiting a sun. And that sun is orbiting a galaxy. And so, and that galaxy, a cluster, and then that orbiting a supercluster, and that supercluster is in the universe, and so on. So if you only see horizontal, you say, oh, I'm just a human being. In fact, we tend to just see very, very close to ourselves. Right? Horizontal, like family, neighbors, work, neighborhood, country. Even country is hard, right? But that's horizontal. If you look vertical, human being on a planet, around the sun, inside a galaxy, you are part of that galaxy, whether you like it or not. So when do you actually experience yourself as the galactic being, the galactic community? Is there any moment that comes through your mind? That there's something bigger that you're part of? We know now that there's planets almost around every star we observe. Do you realize? That's 100 billion stars in one galaxy. That's a lot of planets. Most stars have multiple planets, a lot of planets. And we know as well that there is water everywhere we look. We can't actually find a place in the universe where we don't see spectral lines of water, even between galaxies. So, the universe, and certainly the galaxy, is most likely teeming. I don't know how they're going to translate teeming. I'm sure they can do it. Teeming with life. Everywhere. So think vertical. Because we're about to go vertical. This technology that's coming, based on this connectivity of the structure of space-time, will change your life. So this connected view, the connected universe view, we made a movie about it. Malcolm Carter, for 3.5 years, worked on this movie. Pretty well, all on sweat equity, very little money. And you know, throughout the years, I had so many filmmakers coming to me to say, you know, we're going to make a movie. I'm like, yeah, I heard this before. And then when they realize how much work it is to take a theory like this in physics that involves so many different fields as well, and try to put it in an hour and a half, then usually it doesn't go so well. But Malcolm came to me and said, we're going to make a movie, it's going to be 20 minutes. I'm like, yeah, right. But somehow, I felt that Malcolm had the talent, the expertise. Malcolm was making movies for NASA, for explaining complex ideas in science and making them accessible for the public. And as well, he had the passion. And so he went at it for 3.5 years. It's only been possible because of you guys out there helping out. We ran, at one point, we completely ran out of money after about $250,000 of investment from a nonprofit foundation. And we ran a crowdfunding campaign on Indiegogo, and you guys responded so well. It was the most successful crowdfunding campaign on Indiegogo for a documentary film ever. And that's because of you guys. So I'm really honored. You know what? Since we had a premiere for the movie in LA with all the stars, and I had a tuxedo, and my kids had a tuxedo too. And we were really we're really excited. You guys are actually the first public that's going to see the movie. And I'm on my way to Paris for the Paris premiere, and I'm on my way to London for the London premiere. But here we are in Poland, and you guys get to see it. So I really hope you enjoy it. And afterwards we'll get to talk. Take notes if you want to or don't. I'm going to do a little bit of a presentation afterwards. It'll be short because we'll just do a little math, Don't panic, it won't hurt too much. And then we'll do question and answer, and we'll just talk about it. Sounds good? Yeah. Let's do it. Thank you. Thank you, Captain Picard, for leading through this adventure. It was great to have Patrick Stewart get involved. And did you enjoy it? Yeah. I know I'm here and it's better to talk, so, and I'm sure there's questions, or maybe you guys don't have any questions about this because you got to figure it all out. and I'm happy to talk about it and go through some of the questions. I just want to start my presentation and look at what we can come up with. I just want to talk to you about a few things that are not in the movie, and some of the things that may need a little more clarification. I know the movie has a lot of philosophy. Some people here are more technical.
Yep.
Yeah. So, that was one person. So we're going to do a little physics, but because I want you guys to understand this, because actually it's important to understand it at the most fundamental level, so that if you actually can visualize this, you can connect to it in a much deeper level. Actually, I'm only speaking from my own experience. When I was solving these equations, some of the things I came up with, some of the times when I solved some of these equations and I saw the beauty in the mathematics that was coming out and what it was saying and how accurate it was. In some cases, using enormous numbers to predict very, very, very teeny values. I was just blown away, and although I've been working with this for some 30 years, every time it would give me deeper and deeper understandings of some of those very fundamental principles. And change my optics on the universe and the way things are, at a very fundamental level. So I was wanting to show you some of this because people, it's mentioned in the movie, but I think it's really important to dwell on this. Like, how small is the Planck? Because people say, you're saying that space is not empty, right? But it seems empty to me, right? What is wrong with you? What are you talking about? I don't feel this energy you're talking about, right? What do you make, makes no sense. But then you start to think about it, the space between you and me is full of that energy. Meaning, like, electromagnetic fields are present between you and me in the space everywhere. It's non-trivial amounts. Like, there's infrared, there's X-ray, there's microwaves from all our cell phones, there's radio waves, there's background radiation from the Big Bang, so-called Big Bang, not that I endorse the Big Bang view. There is like all kinds of stuff. There's radio waves. And if you actually have a little radio in here, and you tune the little crystal inside the radio set just to the right frequency, all of a sudden music comes out. Is it because there's a band in the radio? No. The music is not being made inside the radio. See, saying that your consciousness is being made inside your head is the same concept as thinking that the music is being made inside the radio. But the radio is in contact, is capturing information that's in the space between you and me, that's everywhere, right? So we know that stuff is there. Not so long ago, we didn't know that stuff was there. Not so long ago, me saying that today would be like completely heresy. Like, Because all we thought was in the space between you and I was just the visual spectrum of the electromagnetic field. And then we discover all this rest of this stuff. Well, there's electromagnetic waves that are not so long, that are not so easy to detect, that are much smaller. How small? Well, if the electron was the size of the dome at the Vatican, so that an atom would be the dome of the Vatican. Okay, so remember, you're made out of 100 trillion cells. This is to give you an idea of scale. Each cell is made of 100 trillion atoms. And if the dome was one of those atoms, right, which is about 42 meters, then the proton would be like the head of a pin in the middle. Okay, so atoms are already like 100 trillion in one cell, so they're small, right? Well, the proton is even way teenier than an atom. It's very small. So when I say in the movie, you know, that if you took a grain of sand and made it the size of a plum, okay, the proton size would be similar to the distance between, this is the Earth relative to the Sun, right? This is just like a little grain of sand. So the little grain of sand is really teeny relative to the Earth, is really teeny relative to the Sun. So if I made a little plum, the grain of sand, then the proton diameter would be from Alpha Centauri to the Sun. 40 trillion kilometers. So of course, you're not experiencing the Planck field directly. You know, you're kind of missing it, right? You're not measuring it, it's happening, but you don't know it's there. In fact, it's happening, and it is the source of all of your reality, including your consciousness. But you have no way of knowing it's there. Unless you did enough physics, and then all of a sudden it started to become clear, and then you could start to make some experiments in the laboratory, and then you start to discover, oh my God, we're like fish in the ocean. We are swimming in this field of information. And our body are like little biocrystals tapping into this thing, to this information set. But if you are a radio set, capturing some frequency of the Planck field, right, that you're tuning into, what is the dial? So if your body is the radio set, what is the dial on the radio? The dial is your state of emotion, right? Because we know that that's tuning your body, meaning, like, depending on your state of emotion, your heart is beating at a certain rate, the blood is going at a certain rate. All these things are what's oscillating your crystal, right? The lymph system is pumping at a certain rate, your stress level is affecting how much, fluid is going through the whole system. There's spinal cord fluid going up into your brain. Your brain is 90-some% water, and it's circulating, and all this stuff. And so basically, your whole oscillation rate, so you're tuning that dial with your state of emotion. And you know how when you tune the dial a little bit off the radio station, like there's a lot of noise, like, and then a little music, and then, because you're not quite on the channel. Well, in other cases, you're bringing your state of emotion so that you come onto the channel and all of a sudden clarity occurs. It's like, whoa, nice, right? So this is something that's occurring, that you're discovering, that we're discovering, and it's not just some philosophical idea, it actually adds up. Meaning, it actually predicts correctly very fundamental principles in physics, like the mass of the nuclear of an atom, the mass of the electron now, the mass of all the elements in the table of elements. So, I did this by calculating the number of these little plunks inside a semi-cube of space, and then calculating how many of these little plunks there is in the nuclei or in the volume of a proton. And so a proton is really, really small already. It has a volume of 10 to the minus 39. It's a very small volume. But then if I fill it full of plunks and I calculate how many or what's the mass or what's the energy of all these plunks inside that proton, that mass adds up to the mass of the universe. That is, the mass of all the other atoms in the universe is represented holographically through the Planck field in one proton. So that all the information that makes up all the atoms is within one atom. And you're made out of a lot of those things. So can you imagine the amount of information that's present in your body right now? You're talking the mass of the universe, right? In terms of energy. So I found this, and of course, when we measure the mass of a proton, it's not the mass of the universe, right? So why is that? Well, because if we're dealing with a mini black hole, then only a very small percentage of the energy, only a very small percentage of the information is able to come out. So we measure only a teeny weeny bit of how much is there. So I have to come up with an equation that would describe that. Imagine I'm working on an equation, okay? Like, this is how ridiculous this is. And this is, you can imagine the looks I got from my peers when I told them what I was working on. So I'm working on an equation where I'm going to consider all the other atoms, all the other protons in the universe acting on one proton. And by the end of the equation, I got to get the mass of the proton we need. Right? Like, they were like, I don't think so. I would give up on that, I would do something else, maybe give up physics and go bowling or something, Do you have any other talents? Because, the idea that somehow you can write an equation that has in it the mass of the universe, and somehow it's going to nail the mass of one proton is probably very unlikely. So I was working on this and I was racking my head, but then I realized, for instance, from Wheeler, and some of the work that had been done, that this vacuum fluctuation is so high that it's not just chaotically, oscillating, but it actually is creating these micro wormholes, right? These filament, these wormholes that connects things, and I start to realize, wait, this could be the way, a proton is connected to all these other protons, and maybe I can calculate how much information could go through these connections. And wouldn't it be really cool if when I calculate how much information is going through the surface of one proton through this connection, I would get the mass of proton. Like, that would be cool. And it's like, I was thinking, if I'm lucky, I will be like within one order of magnitude. If I'm close, by an order of magnitude, I'll be happy, right? Because I'm using the mass of the universe. And like we're going from the universe to the Planck scale. Those are large scale differences. Okay? Remember, like a grain of sand at the Planck scale, then the proton is 40 trillion kilometers in diameter. So the universe then is like, whoa, really big, right? So I start to think the micro wormhole network. Now, this is something that has started to take root in other physicists' theories. Like one of the greatest physicists in the world right now, Leonard Susskind, is the director of the Theoretical Research Institute at Stanford, starting to talk about a theory where he's relating the fact that particles can be entangled with the wormholes that connects them. And he's starting to realize that actually black holes are connected through wormholes. And that actually is occurring even at the atomic level. So I start to think about that. And I started to think, well, how can I explain this? So I counted the number of Plancks on the surface, because I was thinking maybe each Planck is like the end of a connection of one of the little micro wormholes. So there's all this information inside the volume, but it's restricted. Right? There's a restriction to how the information is able to come out, because there's only a limited amount of wormholes on the surface. So I calculated how many Plancks are on the surface and how many Plancks are on the inside, and as you saw in the movie, I just did a simple ratio between the two, R over eta. R is the number inside, eta is the number outside. This is Cygnus X1, it's a well-known black hole. And when I multiply that by the Planck mass, meaning the mass of one Planck, so I was getting the energy of the ratio of information, right? It gives me the exact mass of the black hole. Exact, right? So that I had solved Einstein's equation for gravity without using Einstein's equation. Right? Usually we get the mass of the black hole using Einstein's equation, but in this case I had just used little Planck fluctuation. I had used quantum particles to solve for an universal gravitational field. So this was saying that Einstein was right to say that space-time is curving to create gravity, but actually he never said what space-time was made of. This is why today, if you ask a physicist what is gravity, they'll tell you, we don't know. We just know that it's space-time curving, but Einstein never described what space-time is made of. So we don't know. this was saying space-time is actually quantized at the very fine level. It looks smooth on a large scale, but it's quantized at the very fine level. Just like the water in the tub looks smooth at the large scale, but if you look closely with a microscope, you see it's quantized with particles we call molecules, right? Hydrogen, oxygen. It's made out of discrete pieces. You guys are following me? Yeah. I'm seeing a lot of blank look. What is he talking about? Just think of it as like the smoothie universe, right? You guys have smoothies in Poland? Yeah? The smoothies have made it to Poland. So, think of like all the little particles in your smoothie when you make it in the morning, right? All co-spinning. The top of the smoothie looks like it's curving. It looks smooth, but it's made out of all the little particles that you put in there, all the good stuff you put in your smoothie in the morning. The same thing. And it was exact. So I'm like, wow, that's amazing. Then I called everybody trying to figure out, I thought this must be known because it's so simple. But, and I was like, did you guys all miss this? Because if this would have been solved by Planck, before Einstein, we would have never had general relativity. Like the curvature would have been understood to be a secondary result of all the Planck spinning. And so I tried to, this is the solution algebraically, because this is geometric, right? But you can unpack this mathematically and you get this beautiful, simple solution geometrically. But then I applied it to the proton to see if my gravitational equation worked for the proton level, for the quantum level. So I did the same thing. I calculated the number on the outside. Look at that. There's 10 to the 40th little Planck on the surface of a proton. That's a large number. 10 with 40 zeros. You might have noticed in your bank account, when you add zeros, it's exponential. It grows fast. Like if you have 4 zeros, it's okay. But if you have 5, it's really nice. If you have 6, it's like, oh, we're doing good. If you have 7, whoa, right? Now imagine 40 zeros, right? That's a lot. It's a big number. Okay? So there's a lot on the surface of a proton because the Plancks are so small. But then I calculated the number inside. You see, 10 to the 60th. Each Planck has a mass of 10 to the minus 5. If you multiply 10 to the 60th by 10 to the minus 5, you get 10 to the 55, which is the mass of the universe. The mass of the universe inside one proton. Okay? So I'm using the mass of the universe in my equation to nail the mass of one proton. You can imagine I was a little nervous doing this calculation. Right? All this, it took me 30 years to get to this. It's so simple. I was like, what is wrong with me that it took me so long, right? My 10-year-old got it. Like when I explained it to you, he's like, Papa, why does it take you so long to figure this out? I'm like, I know. Papa is kind of slow. But, I guess I had to do all the rest of physics to arrive to this. But then I multiplied it by the Planck mass, and sure enough, it outputted the mass of the proton with extreme amount of precision. I was within 0.0012 of the mass measured in laboratory, the co-data mass. I was like, whoa! I was hoping I was going to be in an order of magnitude, right? Like at least 1 or 2 orders of magnitude, I was hoping. Instead, I was within 0.0012 of the mass. I was blown away. I started to float. And I floated for almost like 2.5 weeks, you know, on a big cloud. Everybody, and at the time I had my laboratory in Hawaii, you know, everybody in Hawaii was like, what is wrong with Nassim? Because I was walking around the compound. We had 13 acres, right? So I was walking around the compound with my tablet, with my calculations, not electronic tablet, like, you know, paper, like the old kind. You know, and I was hitting my head, recalculating, hitting my head, this is not, cannot be true. I must have messed up. It's so simple. And then calling colleagues, is this known? No. One of the reasons this is not known is because calculations that are made with the Planck length are typically made using, the symbol is usually script L square, meaning the Planck length square, as if the pixel of the universe would be a square, a two-dimensional square. Well, if you do these calculations with two-dimensional squares, it doesn't add up. It's wrong by huge level of magnitude. Of course, the universe is not making square pixels. And definitely not two-dimensional. Now, you might have seen this in magazines since the holographic, you know, theories have been starting to gain popularity. You know, there's Sutskin, you know, came up, won the war against, the information war against Stephen Hawking by using a holographic view, meaning there was a disagreement that if information fell into a black hole, where did it go? Hawking said it disappeared. And Sutskin said, well, that's not possible because no information or matter can disappear. And so he proved that actually when something falls into a black hole, the information is left on the surface of the black hole in terms of Planck bits of information, and they calculated it, and it gives the right temperature for the black hole. It's called entropy. This is called the holographic principle. And so it gives within, you know, it's actually a fourth of the number of Plancks gives the entropy of the black hole. And so Stephen Hawking conceded the bet that he had lost the bet against. It's a very famous thing. But when those ideas were put together, this is why you might have seen in popular magazine. Did you ever see this? Is our universe a two-dimensional hologram? Did you ever see that on the cover of magazines? I assure you, the universe is not two-dimensional. Oh my God! This is what happened. We come up with ideas, models in mathematics, and because we come up with it, we think that must be the way the universe is. But that is incorrect. Like, there is no such thing as a two-dimensional plane. That is a concept of mathematics, not a reality, right? There is, you know, you might say, well, this is two-dimensional. No, it's not. This string has thickness. the photons that are hitting this screen have volumes. They're not, like, there's, the concept of two-dimension is in your head. Like, in your head, if I draw a little happy face on a piece of paper, you might say that's two-dimensional, but it's not. Like, the reality is that the ink I'm using has thickness, the paper has thickness. You see how we get caught in this problem? So what I did in this equation is I made those spheres. And if I had a grease ball, I could show you, but so I didn't make a Planck pixel square, I made a Planck pixel sphere. And when I did the calculations with spheres, then it came out, right? It came out exactly so that the solution said that the spheres are packed in such a way that no space remains. It's called space-filling packing, right? There's no, so you can't put the spheres side by side because then you would have holes in between. This is why I show the spheres intersecting here, right? Because they're like interference pattern, which is what a hologram is. It's interference pattern. So the spheres are interfering with each other, interlocked. And that actually makes up a very ancient symbol that you find in many cultures all around the world, called the flower of life, right? You guys all see that? It's very common. Yeah, it's on rings nowadays, it's on pendants, it's on t-shirts, right? It comes from very long time ago. It's actually the exact solution to quantum gravity. In ancient, symbolism, it was said that this symbol was the foundation of the structure of the universe. Well, it is. And I didn't do it on purpose. That is how the equation came out. Is that crazy or what? So, actually, the solution was able, when I did the solution, of course, as you saw in the movie, I was able to predict because, because of the way the little pixels work out, I was able to predict exactly what should be the radius of that little proton. And then they measured it I published, and like a month and a half later, when I published and I made the prediction, the people that was working with me, they were like, I don't know if you should put that prediction in there. Because, it's kind of gutsy. Because my prediction is 4% smaller than what the standard model would predict the proton should be. So it's like, you're basically telling them they're wrong by 4%, which in quantum theory is a lot. Okay? But I put it in there, and then the measurement, and I thought maybe I will die, and the measurement of the proton radius will never be measured during my lifetime. Because it's so hard to measure. And I didn't know there was an accelerator exactly at the same time as I was writing these equations that was trying to measure the radius of the proton more precisely than ever. Because it's really important in physics. They were actually trying to support and confirm the standard model. And so they made the measurement, but the measurement was 4% off the standard model, and my prediction was within 0.00036 of the predicted value. So not only was it very close, but I'm inside the margin of error of the predicted value. That means that I'm claiming that my number is exact. And they're getting closer to it. Right? So, you know. So basically, we only see a very small portion of the information available. The very teeny weeny portion is available to us. But there is much more there. The rest of the universe is actually attached to the little protons. And so that everything is entangled. You know that we can entangle particles in a laboratory, right? Einstein called it spooky action at a distance. You can actually get particles to become entangled, and you can have them miles and miles apart. And if you change this little particle, the other one over there changes instantaneously. Even if the particle is further than the information would have time to get to it at the speed of light, the particle changes. So we know the distance doesn't matter. The particle could be on the other side of the universe. If I change this one, that one changes. Now we're starting to realize that the reason why that's happening is because there's little teeny wormholes that connects the particles. And when, how do you say wormholes in Polish? What are they?
Czarna dziura.
Czarna dziura. That's a black hole.
Yeah, that's the time.
Ah, czarna dziura. Okay, so,
Tunel.
tunnel.
Yeah.
Oh, tunnel. Oh, yeah, tunnel. Oh, nice. I'm getting it. I'm gonna learn this. Okay. We're gonna have to continue this in private because it could get ugly. So
Have you seen the phantom photography in internet? Phantom photography.
of the wormhole?
No, but have you seen how it's kind of picture?
Oh, yeah, of the connection.
That's
Yes.
floating around.
Yeah. And so anyway, I don't want to take too much time, but that's my paper that just got published, on consciousness. See, I changed the word space-time to space-memory, because without memory, there is no time. Right? See, if you can't remember the moment before, there is no continuous linear time. So space-time is inaccurate. Space-memory is accurate.
Which is feedback.
Right? But, So, feedback. Yeah. Meaning that space has information in it and you're leaving memory imprints. When you remember something, you're actually retrieving information from the structure of the vacuum that you left in that place. You're still entangled with it. So you say, but these particles we can see are not entangled. You know that now we can entangle large objects like diamonds? We have being able to entangle diamonds in laboratories so that we can have 2 diamonds in a laboratory and we hit this diamond with a laser and the other diamond over there vibrates like it's being hit by the laser. Right? So, but you're going to say, well, not all diamonds are entangled. That's because, so we see entanglement and then we see what we call decoherency or disentanglement, right? But we actually don't see disentanglement. What we see is that this particle used to be connected directly with this one, but now it's connected to this one, 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 connected to this one, to this one, to this one, to this one. And because of lag across huge scales, like universal scales, right? the lag is very small, but because of universal scale lag, it appears that this one is not reacting instantaneously. Do you see what I'm saying? It's never disconnected. It's either connected more directly or indirectly. And this is what these equations are telling us. So of course, that led to that paper where I'm describing consciousness as this connectivity in space. So a unified space memory network from cosmological level to consciousness. So it actually is like you can actually go, so your consciousness has all of the information of all of the other protons in the universe in each one of your protons. So you actually have access to all the information in the universe. When I'm telling you things, I'm not actually teaching you anything. I'm just helping you remember what you actually already know. And you can tell what's more accurate and what's not so accurate. This is why this work is taking off. Because the population can tell what's accurate and what is not so accurate. And so, and now the electron paper. So since the proton success, I tried to get the electron solution, and I'm not going to run you through all of it, because I want to take questions. But you can see that I did the same thing. Eta sub E is eta for a Bohr radius, for the hydrogen atom. So I took the number of Plancks on the hydrogen atom, the number of Plancks on the inside, multiplied it by m sub L, which is the Planck mass. But in this equation, there's 1 over 2 alpha, because there's a change in velocity. Larger you go, the proton is spinning at the speed of light, but the electron is slowed down that far away. Imagine like the center of the galaxy is a black hole spinning very, very fast, but the star on the edge of the galaxy is going much slower, right? So I had to consider that. So so when I took the velocity at 1 over 2 alpha, boom, the value for the electron came out with the precision of 99.999999998%. And you know, alpha is 1 over 1, it's called a fine structure constant, is 1 over 137. That is usually only thrown in quantum physics. Like it's one of those free parameters that, quantum physicists throw in to make the equations come out. But in this case, it explains what is alpha. Because alpha is actually the velocity at the edge of, the Bohr radius. And then we did this, we did this for all the atoms of the table of elements, and we got the whole table of elements. So we can actually now predict all of matter, all the things we see, just with this simple holographic solution. And spin, right? The velocity at different radius. And we're able to output all these very fundamental constants, like the Reinberg constants, and the mass difference between the electron and the proton, and so on. It starts to explain a lot of things. And these geometry have very specific structures. So so that you can think about it. Not playing. There we go. So that if you put a sphere, if you put a tetrahedron inside each one of the little Planck spheres, then you can look at how the spheres, they're not static, right? They're spinning. So you can see how they're spinning around each other and how the information is moving from inside to outside the event horizon. You see? So that in the middle, it's going from a point to a space, back to a point, back to a space. See that? And all of the geometry we see in nature emerge from it. You can get the icosahedron, the dodecahedron, the octahedron. All of the geometry we see emerging in nature all around us can be extrapolated from the movement of the Planck at the quantum level. And this is with the Plancks attached to it. And you can see, you know, we keep growing it here, so we're going to grow it to one side. And you can see that when when we make the movement again, see, one side gets bigger, one side gets smaller, one side gets bigger, one side gets smaller. This is very much like the ventricula of the heart, the way they beat. Okay? Even your heart structure is replicating what's occurring at the Planck scale of creation. And now we're zooming out, trying to show, you know, of course, these are the wrong scale, you know. Because, of course, on the proton, you wouldn't see the Plancks. It'd be too small. But we're trying to express how the information is moving in and out of the surface of the Planck in terms of geometry, and how that geometry is replicated across scale to produce nature. So, you know, we could go on, but I really want to take questions, and I really don't want to go to bed at 4 in the morning with all you guys. I went to bed at 2 last night, slept 3 hours to get here. So, 4 hours. So, but what's really cool, I thought that was really cool, is that if I calculate the number of little Planck bits of information on the surface of all the protons, and then I calculated how many bits of information are on the surface of the universe, they're equivalent, so that every little wormhole on the surface of every proton connects eventually to a wormhole on the surface of the universe, so that every bit of information in terms of protons inside our universe is expressed on the surface of our universe. And this gives a new view of the way universes are created. Because instead of a Big Bang, this means that protons, very small amount, but some proton could escape our universe. And when a proton would escape our universe, you would arrive in a larger universe that has a much lower density. So it would automatically expand extremely fast, because there's 10 to the 55 grams of energy in there. So it would just become very large. It would become the size of our universe very quickly, which is what we see when we look back in time. So it wasn't a Big Bang. So now you can start to visualize the surface of universes with forming new universes as little protons escape. And as these new universes push the vacuum outside that universe back in the universe, then you can imagine protons being generated inside our universe in a continuous creation process. This is why our universe expands, is because it's learning about itself, so it needs more surface to put all the information, all the holographic Planck structures funny, when we were writing this paper, which is unpublished, I haven't published this yet because it's, you know, a little bit controversial. Kind of my style. I'm trying to reduce the amount of tomatoes that are coming my way, but I'm not doing so good. Luckily, I have Italian blood, so I can make pasta with all the tomatoes, make good sauce. But you know, this, when I was writing this paper, which is unpublished, which is in 2013, we're finishing it now finally. We were excited to find that Einstein published in 2013 at the same time as we were writing it. Did you know that Einstein published a paper in 2013? No. Right, I was really surprised too, because he had written a paper that was left in a library in Tel Aviv, and that was just recovered in 2013. It was just discovered. And this paper was Einstein giving a new interpretation of universal evolution, not using the Big Bang. He was trying to find a better solution than the Big Bang. He didn't like the Big Bang. And because it doesn't say anything, you know, the Big Bang just says there was nothing and then there was everything. You know, not quite physics, right? Just like a little, you know, free parameter that they were thrown in, like everything. So, you know, little free parameter, right? So Einstein was trying to do something a little better. So he actually, in that paper, remarkably, Einstein theorized, and you can look it up, that protons were being created inside our universe as a result of vacuum energy fluctuation. See, he was already thinking about that. Right? That's why I cite him in the movie. And that protons were escaping our universe at the same rate, so that there was a continuous creation process. So in our paper that we will publish soon, we're citing Einstein 2013. Right? He was on our side. It was very nice of him to come to help me, you know, 100 years later. And it's like, thank you, Einstein. He was on it. Yeah, I'm excited. So, so that if I take a little proton, right, and I expand it to the size of the universe, remember the vacuum energy inside one proton is 10 to the 55 grams per proton volume? Well, when I grow it to the size of the universe, it becomes 10 to the minus 29 grams per centimeter cube, which just happens to be the value of the so-called dark energy. So now I can explain the 70-some%, the mass of the universe that's missing in dark energy. It's not missing anymore. I found it. So this leads, of course, directly to technology. This is a technology I'm building in my laboratory, and I can do remarkable things with it, because I can couple to the vacuum and make my own little smoothie, right? The universe is making smoothies. We can make smoothies too, right? And we can spin the structure of the vacuum at very, you know, all you need is a high-density magnetic field, the right geometry, and enough velocity. So we can do that, right? And this will lead to a completely different world very quickly. If not coming out of my laboratory, coming out of other laboratories that are getting very close to it as well. like people in Finland that are spinning superconductive disks at high velocity and getting gravitational effects and so on. So it's coming, you guys. Don't despair. But there are many things, not only in terms of gravity control, in terms of energy production, but like imagine, we're going to be, there's 10 to the 93 grams per centimeter cube of energy in terms of Planck energy. If we extract 1/1000000000 of a percent of what's in the Planck field, we can run the planet for thousands of years in terms of energy. And then when we curve it at high velocity, we can create gravitational waves. We can create gravitational effect in which the craft is literally falling into a black hole that's ahead of itself. Just like when you put a carrot in front of a donkey, you know, and it keeps going. Well, we create like a depression in front of the ship. We accelerate towards it, right? So gravity control is on its way. And, you know, as I said, I know you might think like I'm a crazy guy out there, but NASA is working on this as well, you know. There's a section of NASA that's trying to produce a warp drive. If you look up Sonny White, you know, he's been working on it for a while, trying to get the vacuum to curve. So this technology is being built, and some of it has been built. So thank you so much, everybody.